Hello everyone, welcome back to Sulekha Physics classes. Hope you all are doing well. Today in this lecture, we will discuss about measurement of length, mass and time. In the previous lecture, we already discussed about physical quantity, those quantity which can be measured right now, and there are two types of mainly physical quantity. One is fundamental physical quantity, or you can say base physical quantity, and another one is derived physical quantity, which depends on this fundamental physical quantity. And there are 7 fundamental physical quantity right now. Out of those 7, 3 fundamental physical quantity are mostly used, that is length, mass and time. So in today's lecture, we will discuss how you can measure length, mass and time. If a length is very small or larger distance, larger length, how you measure all these things in this lecture we will discuss. Okay. So before starting this one, you must know about order of magnitude. What is its meaning? Order of magnitude. It is the power of 10 which is closest to its magnitude. It does not tells about exact value. It just gives an idea about how much big or small any physical quantity is. For example, radius of Earth. Here I have written 2 into 10 to the power 7. Here power is 7. So order of magnitude of this radius of Earth is 7. In this way, you can easily determine how much this physical quantity, this object is larger or smaller, right now 10 to the power 7 you can easily determine. For example, suppose size of any object is 2.1 into 10 to the power minus 2. So here power is what? Minus 2. So order is minus 2. This order represents how much this how small this object is right now. So this order of magnitude gives an idea about how close this value is right now. It does not give exact value, it just gives an idea how much small or big any physical quantity is, right? So you must know about order. Now I am going to start today's topic, that is measurement of first length, then mass, then time. So first, measurement of length. Now first thing is, what is this length? What is the concept of length? Suppose I have this marker. This side is at this point and this side this point. So distance between these 2 points is what? Length of the marker. So you can write length is distance of separation between any 2 points, right? Now what is the range of length? Range gives an idea about minimum and maximum value. Up to which length you can measure length. What is the minimum value? What is the maximum value? This gives range of length. So here I have written range of length. You can measure with the help of any measuring instrument is 10 to the power minus 16 meter to 10 to the power 26 meter. 10 to the power minus 16 meter is minimum value. Right now? Sorry, minimum. And this 10 to the power 26 is maximum value which you can measure. 10 to the power 26 is nothing but size of universe. And 10 to the power minus 60 meter is diameter of electron. Right? 10 to the power, between this many range come 10 to the power minus 14 meter, that is size of nucleus. Right now? Or size of anything, pen, pencil, marker, size of nucleus, anything, right? So this is the range between which you can measure the length of any physical quantity. So now, what are different methods to measure this range? 10 to the minus 16 meter to 10 to the power 26 meter. There are 2 main methods to measure length. One is direct method, another one is indirect method. So please take a screenshot of this one first. Now, methods for measurement of length. There are 2 methods. First one is direct method, another one is indirect method. In direct method, we can use meter scale, vernier calipers, screw gauge and spherometer to measure different distances. With the help of meter scale, you can measure the length between 10 to the power minus 3 meter to 10 to the power 2 meter. Between these lengths, you can easily measure with the help of meter scale, right? Then vernier caliper, with the help of vernier caliper, you can measure up to 10 to the power minus 4 meters smaller length, right? And then a screw gauge and a spherometer, with the help of this screw gauge, you can measure up to 10 to the power minus 5 meter small length, right? And other smaller length you can also use to determine the size of electrons, atoms, nucleus. That is electron microscope. You can also use to measure electron microscope to measure size of electron, right? Atoms, nucleus. So this one is also. So these comes under direct method, right? Now to measure longer distance, for larger distance you can't measure directly. You can use indirect method to measure larger distance. So for larger distance, indirect method is used. In this one there are different methods are there. First one is parallax method. Parallax method is used to measure the distance of different planets from the Earth. For that one, parallax method is used. Next, second one is echo method or reflection method. In this method, echo or sound is sent from observer to suppose hill, and from that hill, sound is reflected back, and you can measure the time between from observer to hill and then come back to this observer, and you can easily, you know the velocity of sound, you can easily measure the distance with the help of this echo method or reflection method. Next one is laser method. What is the full form of this laser? Full form of laser is light amplification by a stimulated emission of radiation. And write light amplification. You can study about laser in the higher classes. Light amplification by a stimulated, there are different types of emission, stimulated emission. Light amplification by a stimulated emission of radiation. This is full form of laser. And in this laser method, laser beam is used to determine larger distance, right? Then next one is radar method. It is also used to measure larger distance. Then sonar method, sound navigation and ranging. What is the full form of this sonar? Full form of this sonar is sound navigation and ranging. In this sonar method, high frequency waves, or you can say ultrasonic waves, are sent to measure the distance of submarine hills or anything larger distance, right? And what is the full form of this radar? Radio detection and ranging. Radio detection and ranging. Here radio waves are sent to measure larger distances. And then next one is triangular method to determine the height of a tree, height of the pole. You have to use triangular method, and here trigonometry is applied. So different methods for larger distance, but in your syllabus only parallax method is there. So you have to study in detail about this parallax method. First you take a screenshot of this one. Now I am going to discuss about this parallax method in detail. This method is used to measure distance of planets or stars from the Earth, which is very larger distance. So this parallax method is an indirect method to measure larger distance, and it is especially used to measure distance of planets or any astronomical bodies from the Earth. So in this method you must know what do you mean by this parallax. Okay, suppose this is a marker, right? And if you close your left eye and with the help of right eye, you observe this point of the marker, right? First time. Then after that, if you close your right eye, then you observe with the help of left eye, you observe this tip of this marker. It means there is apparent change in position of the object when you observe from two different positions, right now? So this parallax is nothing but apparent change in position of object when it is observed from two different points of observation. Suppose one point of observation. Suppose this is your left eye A and this is your right eye B. When you observe this object from B point, you get this point, and when you observe this object from A point, you observe this point. So there is an apparent change in position of object when it is observed from two different points of observation. This phenomena is called parallax, right? What is basis? The distance between these two points of observation. This is called basis, right? And then next term is parallactic angle. All these terms are important. In 1 marks it become parallactic angle. The angle subtended by the basis with the object. This one is basis, this one is object here. And this is the angle subtended by this basis with the object. This angle theta is called parallactic angle. And so hope it's clear what is parallax, what is basis, distance between two points of observation, and what is parallactic angle. Now how you measure distance of any planets from the surface of Earth. Here distance of moon or any planet from the surface of, suppose this is any planet, object is here, and this one is Earth's surface, and you are observing from two different points from the Earth. When you observe this planet from A point of observation, it makes parallactic angle theta 1. When you observe this object or this planet from B point, then in that case parallactic angle is theta 2. So if this one is theta, this angle is also theta. If this one is theta 2, this angle is also theta 2. So total this angle theta 1 plus theta 2 is theta. This is total parallactic angle made by this basis with this object or let's say planet. And you know, Earth revolves around the sun. So this is the position of sun. Around this sun, Earth revolves, right? So you suppose these 2 points of observation are two diametrically opposite end of the Earth. It means this represents diameter of the Earth. And this diameter of the Earth is nothing but here basis. What is this? Basis. These are two different positions on the surface of the Earth from which you observe this planets. So distance between 2 points of observation is basis. You can take it as B. So this distance AB is B. And this theta 1 plus theta 2 is total parallactic angle theta. And this A and B are two different points of observation of Earth on Earth separated by a distance, this B. So A and B are two different positions. Theta is total parallactic angle. Now you know one relation. If this angle is very small, right? Suppose this is this object and this one is arc and this one is radius, right? Suppose this is a circle. Okay. So if this angle theta is very small, then there is one relation. Theta equal to arc by radius. So if this distance, this theta is very small, this arc can be assumed as basis, right? Now if distance is very large and these 2 point observations are very small, right, then this arc is replaced by this basis. Okay, so this distance AB arc is basis B and this angle theta is arc by radius. I think you know this relation, angle equal to arc by radius. Here arc is what? Because this angle theta is very small, this arc is nothing but distance between 2 points of observation, that is B. So theta equal to B and S. S is what? Distance of this planet from the Earth surface. Here this is the radius. If you draw around this, Earth is there right now. So this is the distance of the planet from the Earth surface. Here it acts like a radius. So in this way you calculate theta equal to what? B by S. S is the distance from the planet to the Earth's surface. And in this way you can calculate S equal to B by theta. So using this parallax method, you can easily measure distance of any planet or astronomical body or stars from the Earth's surface. So this is about parallax method. Using this method, you can also calculate the diameter of this planet. Suppose diameter of the moon you want to calculate. So how you calculate? Okay, first you take a screenshot of this one. Okay, now using the same parallax method, you have to measure size of planet or any astronomical object. How? This parallax method is actually very important from examination point of view. Okay, it may come in 3 marks or 5 marks question also. So, if you know the distance between the planet from the Earth's surface, you can easily find the size of the planet. Suppose this is a planet, suppose here it is moon, and this AB is the diameter of the moon. From the 2 points on the moon, you observe this Earth's surface, right? So this acts as a basis right now, and this distance from the moon to the Earth's surface here is S, right? And you know this diameter of the moon makes an angle theta with the Earth's surface. If you know all these things, you can easily determine the diameter of this moon AB. So here AB is diameter of the moon, theta is the angle subtended by moon on the Earth's surface, and S is distance of moon from the Earth. Now you know this theta equal to this diameter of the moon acts as if theta is small, acts as an arc, right? So this arc and this becomes radius, arc by radius. So arc is AB diameter by S, then AB equal to S into theta, or you can write D diameter equal to S into theta. This gives diameter of moon or any planet. From here, if you know the distance of the moon or any planet from the Earth's surface, this distance is known. Theta is also known. You can measure using telescope. Right now, if these two quantities are known, you can easily find the diameter of the planet, right? In this way, you can use parallax method to measure size of the planet. Okay, so please revise this one. This topic is very important. Now after this, some common practical units. For larger distance, there are different units are there. For smaller distance, different units are there. For larger distance, we can use astronomical unit, and in one astronomical unit 1.496 into 10 to the power 11 meter. It is distance of sun from the earth from any planet. You can measure it in astronomical unit. Light years distance traveled by light in 1 year, and it is equal to 9.46 into 10 to the power 15 meter. Then next one is parsec, and 1 parsec equal to 3.1 into 10 to the power 16 meter. These are units for larger distance. From all these three units, parsec is greater than light year, greater than astronomical unit, right? And for smaller distance, you know Fermi, 1 Fermi, 10 to the minus 15 meter, angstrom in 1 angstrom, 10 to the minus 10 meter, nanometer, 1 nanometer, 10 to the minus 9 meter, and then micron, 1 micrometer equal to 10 to the minus 6 meter. These are used for smaller length, right? So these are different units for larger and smaller distance. Please take a screenshot of this one. Next is measurement of mass. First, what is mass? What is the concept of mass? How you define mass? Mass of a body is the quantity of matter contained in that body. It is the basic property of matter. And its SI unit is what? SI unit of mass is kg. And for very small mass, atomic mass unit is used. You studied about atomic mass unit in chemistry. 1 atomic mass unit is 1 by 12th mass of carbon 12 atom. Now, what is range of masses? Mass can be measured between these range. Minimum value is 10 to the minus 30 kg to 10 to the power 55 kg. 10 to the minus 30 kg is mass of electron. Up to this, you can measure mass of electron. Up to this mass, you can easily measure. And 10 to 55 kg is mass of universe. You can also measure mass of universe. Between these masses, you can easily measure range of masses. Minimum value is 10 to minus 30 kg, and maximum you can measure 10 to 55 kg. Now, there are two types of masses. One is inertial mass, another one is gravitational mass. You know, inertial mass is those mass which acts under external force, which follow Newton's law, inertial law, right? And gravitational mass is those mass of the body which is under action of gravity. So inertial mass is measured by inertial balance, and gravitational mass is measured by physical balance, right? Just remember these points, okay? Now to measure large mass and small mass, which method is used? To measure larger masses like that of mass of planet, stars, sun, you can use gravitational method is used, right? And to measure small mass like mass of atoms and subatomic particles, it is measured by using mass spectrograph method. So this is just about little bit about measurement of mass. In last one is measurement of time. What is SI unit of time? SI unit of time is second, and it is measured by atomic clock. Atomic clock is based upon periodic vibrations of cesium atom, Cs atom, right? This atomic clock is based on periodic vibrations of cesium atom. 1 second is equal to some vibrations of cesium atom. So no need to remember that one. Just this atomic clock is based upon periodic vibrations of cesium atom. What is the range of time? It is between 10 to minus 24 second to 10 to minus 17 second. 10 to minus 4 second is life of unstable particle, and maximum time you can measure, that was 17 second. This is age of universe. Okay. Now different instruments are used to measure time: electric oscillator, then solar clock, quartz crystal clock, atomic clock, radioactive dating, which is used to measure the age of fossil fuels, right? So there are different methods to measure time. It's not so important, but still you have to remember these things. Please take a screenshot of this one. After this, I am going to end the class. Hope you understood today's topic, right, students? So please keep revising and stay tuned with this channel and wait for the next video. Thank you.